All right, sorry about that technical mishap with my stylus, but I think it's fixed. Hopefully we won't have any more troubles with this video, and we'll pick right back up with talking about symmetry about the origin. So we also had a numerical way to classify this, where we knew that if x, y is on graph, and so is negative x, negative y. And maybe with this, you can guess what the condition for odd functions is going to be. F of x equals x cubed is an odd function. I'm just going to recreate the graph down here for us. We can keep looking at it. And we say that a function is odd if f of x equals y implies f of negative x equals negative y. So xy is on the graph, implies negative x, negative y is on the graph. And it's pretty easy to check that x cubed is odd. We have f of x equals x cubed. F of negative x equals negative x cubed, which equals negative 1 cubed x cubed, which equals negative x cubed. So it's odd. Really, this is just different terminology for having symmetry. The reason why we have to make this terminology of even and odd instead of saying symmetry is that a function isn't really a graph. We can graph a function, but a function itself isn't a graph. So therefore, we're saying that it has these two properties, and the properties relate to the numbers that we plug in. And those properties tell us that the graph has symmetry. So it's just a little bit of a technicality. But a good way to think about odd is having that symmetry about the origin, where you plug in positive values and you get a value out. When you plug in a negative value, you get the opposite value out. And even functions, we get a reflection across the x and y axis. All right, I would recommend doing the MyMathLab homework and just going through a lot of examples of even and odd functions. All right. And there'll be one more video for 3.3, so bear with me.